let's take a look at how to graph rational functions. Rational functions are given in this general form that you see here. Sometimes instead of y, you can also have f of x. That means the same thing as y. This is the equation that shows all of the transformations that are happening to your parent function y equals 1 over x. So there's several things that are happening here. If you see that you're adding or subtracting in the denominator, that means that there's an h value, and that's going to be shifting your graph left or right. Um, with that, then your vertical asymptote is shifting with it. So this is your vertical asymptote. Your vertical asymptote equation is x equals whatever that h value is, and you have to remember that h is always the opposite of what you see. So if you see x minus 3, for example, it's actually going to the right 3. Okay, then if you see that you're adding or subtracting on the outside of the fraction, that's your k value, and that's going to shift the graph up or down. And with that, then, this is going to be shifting your horizontal asymptote, which you get by the equation y equals k, and k is what you see. So if you see, for example, plus 7, it's going to be going up 7. Okay, and then at the top of the fraction, and again, in our parent graph, we have 1. So if you see a number that's not 1, that means that you are stretching or shrinking the curve. That does not affect your asymptotes at all. It just is affecting how the curve is going to look. And then if it's negative, you're going to be reflecting it. So in general, your parent function has a curve that looks like this. If you had a negative a value and it reflects, then your curves are going to end up in the opposite quadrants. Okay, so let's take a look at an example. So this is on your test review for chapter 6. This is number 13, again on your test review. Okay, so going through each of these questions here, we have this equation 2 over x plus 5 plus 4. So I have all three transformations. I'm adding the bottom, outside, and I have a number on top. So let's start with identifying the horizontal asymptotes. So going back over here to my guide, the horizontal asymptote is looking at your k value, and that is in our equation of plus 4. So the horizontal asymptote is that y equals 4. So I'm going to put that on the graph right away. So I go to where y equals 4, and I make a dashed line going horizontally, labeling it as y equals 4. So remember, this line is representing every single point that has a y value of 4. Okay, going on to the vertical asymptote. So again, remember your vertical asymptote is looking at that h value, remembering that h is always opposite. So here we have a plus 5, so our equation is x equals a negative 5. So then we go to negative 5 on the x-axis, and we make a dashed line going through there. So this is representing every x value that is equal to negative 5. Okay, next up is identifying the domain and the range. And both of these have a direct correlation to what your asymptotes are. So remember that domain is referring to all possible x values of your function, and the range is referring to all possible y values of the function. So it can be, for both of these, every single number that you can imagine in the reals, so all real numbers, except for the domain being x values, you have this asymptote at x equals negative 5, meaning nowhere on your function is x going to equal negative 5. So it's all real numbers, but x cannot equal negative 5. The range, then, all real numbers, but y cannot equal 4. And that was from up here. You have an asymptote at y equals 4, so you're not going to have any y values at 4. Okay, the x and the y intercepts. The x-intercept is where your graph crosses the x-axis. You have some x value there when y is 0. And then your y-intercept is where it crosses the y-axis, so that order pair is going to be 0, y. We can solve for both of those, but I always hold off until I fill out the table because we might see in the table a 0 somewhere for x or a 0 somewhere for y. So let's wait and fill that out. Okay, so we are ready to fill out the table. To start off filling out the table, I visualize kind of cutting it in half, and I base it all off of my vertical asymptote. So I'm going to start my table here in the middle at x equals -5. When we look in our calculators, we're going to see an error there, and that's because the function doesn't exist at x equals -5. So from there, we're going to pick 3 nice points above -5 in the table and the first 3 nice points below -5 in the table. So let's go take a look at our calculators. So to enter in an equation, you go to y equals, and you're going to type in 2 divided by, you need to put the denominator in parentheses, unless you fancy fraction, x plus 5, close the parentheses, and then plus 4. Just in case you're using a different calculator than what we did in class, you need to make sure your table is set up appropriately. If you hit second and then table set, like right now my table is at -48. That's not going to be very good. So if I just switch that to 0, and the main part here, this should be 0.5. Once you have that change, it's not going to change unless you go back in there. All right, top right, hit graph to see what the graph is supposed to look like. And so far that matches where we have our asymptotes. So now let's see where the points are. So to look at the table, you hit second and that same button. And here's our table. So I said that we're going to start our table at x equals -5. So I have to go up a couple times. There's -5. It says error. Okay, so that's because there's an asymptote at -5. Go up a couple more until I see 3 nice points. So we have 3 nice points here that we're going to use in our table. So at x equals -5, this was kind of the middle of our table. These two right here and this one right here. So copy those down on your paper, and then we're going to use those 2 points and those points right there. Okay, so going back to the table then, copying down those values, we have -7, 3, -6, 2, -5.5, and 0, -4.58, -4, 6, and -3, 5. Okay, so I'm plotting these points, just, plotting away. So -7, 1, 2, 3, -6, 2, -5.50. Ooh, and I'm thinking down here, intercepts. Which intercept is this? So x when y equals 0, that's our x-intercept. So our x-intercept is -5.5, comma 0. We'll go back to the y-intercept in a second. Going forward, then plotting my points, -4.58, -4.5, 5, 6, 7, 8, -4, 3, 4, 6, and -3, 5. Okay, so you have 3 points on each side. When you connect your points, you're going to get really close to your asymptotes. Not ever actually touching them. Please include arrows at the ends because these curves go on forever. All right, so there's our graph. Oops, I forgot an arrow up here. All right, last thing is we got to go back and figure out our y-intercept. So to get that y-intercept, if we go into your table, and if we keep scrolling one of the directions, can we find when x equals 0? And you will always see your x-intercept, your y-intercept in the table because of how your table is set up. You're going to always see where x equals 0. The only time you're not going to actually see it is if there happens to be an asymptote there, and then it would say error. So right here we have x equals 0. Oh, it's scrolling. Stop. 0, 4.4. So right here gives us our asymptote. Or not our asymptote, our intercept. So 0, 4.4. All right, so I'm going to quickly go through how you can solve for your intercept just in case you don't see it in your table. So again, you're going to see this one in your table because x equals 0, and that's your table, you can always scroll and find where x equals 0. But to calculate your x-intercept again is when y equals 0. So if you go back to your equation, you're going to plug 0 in for y. So 0 equals 2 over x plus 5 plus 4, and now you have to solve this equation. So subtract 4 to both sides. Goodbye, 4s. Negative 4 equals 2 over x plus 5. Next thing is you're going to multiply both sides by this x plus 5. Technically, it's over 1, which is going to cancel those. And you have to multiply this side by x plus 5. So right side you have equals 2. Left side you have to distribute that negative 4. Okay, then add the 20 over to the other side. So you have 22. And then divide everything by negative 4. So 22 divided by negative 4 is negative 5.5, which we had in our table. And that is how you graph a rational function.